All right, welcome to our Materials Characterization Lab. Inside this lab, we have a bunch of really neat looking scientific equipment that helps us make really thin materials. A lot of the materials, functional materials we use, especially in things like all of the electronics we know and love, happen to have to be very small. And when I say very small, I mean almost 1,000 times thinner than the human hair in some cases. So our tool over here is our sputtering tool. And Dr. Inglefield is running our sputtering tool, which can deposit a whole variety of materials, just depending on what you load into the shiny chamber over there. And it gives us a lot of versatility in the types of thin film materials we make for a variety of applications. Over here, we have our atomic layer deposition system, which is really neat because it can deposit a material one atomic layer at a time. Our sputtering system is currently really running. This one we're still working on and getting it running in process of testing. In this particular lab, we focus very heavily on making these materials. Many of these other tools in here are really to understand those materials. And as physicists, what we really care about are the structural, electronic, and optical properties of all of these materials. We also have one other coater in this room. This is a carbon coater. And our carbon coater here, I think it does a little bit more than just carbon, but is actually part of our geosciences department. But it can also deposit materials too. So we have a lot of capability in our lab to make different things for a lot of different applications.
Hi everybody, we're just down the hall from the materials lab in our microscopy room, and we have here two tools that we use all the time to characterize materials here at Weber State. The first one is a scanning electron microscope. If you've seen pictures of bacteria or insects up close or something spectacular like that, probably taken with a microscope very much like this one. We use this tool in physics to get a sense of morphology and structure of a material. The electrons that are accelerated down here and hit our target material, that energy can create X-rays. We can also tell composition with this tool. So this tool tells us the shape of things down to micrometer and submicrometer scale, and then also tells us what elements a sample is made of. Down here we have a complementary tool called an atomic force microscope, or AFM. This tool gets us even higher resolution images of a sample surface. And it does this by sliding a probe tip back and forth across the surface of the sample. Laser is bounced off the back of that probe tip. Small changes in the position of that tip deflect the laser quite a bit, and we can measure accurately topographic features down to atomic scale. Whereas the SEM gives us sort of a versatile way of zooming in on a sample. This gives us true quantitative measurements of the sizes of features on a sample down to an atomic scale. Using these two tools together, we can figure out if we made what we think we made down the hall in the materials lab.